Where's 19?
We'll look at 19. Prior to that, I wanted to look at on the first page, I think it's number 9 on the first page. But just a reminder, tomorrow is your Chapter 6 test. I will be collecting the review worksheet and looking at it. Yes, it might be a quick glance at it, but I think the numbers memorized pretty quickly of what the problem should be. So I will be kind of looking at that and making sure that the answers look like they should and that you especially have supporting work for them to get the credit. So if you start with number 5 on here. Number 5, we have the cube root of 8y to the 6 divided by 12. And how would you solve a problem with a cube root? Mason?
You cube root each side.
Right, so you want to cube root each side, so we're cube rooting the 8y to the 6. We're also cube rooting the z to the 12. And Mason, when you cube root 8, you get 2. The y becomes
Y squared.
y. Why does y become y squared?
Because you have to divide the x by the root.
So you're really dividing the exponent by 3. That's what a root actually does because it makes it into a fraction. So it's the denominator of the fraction where the 6 is the exponent, the power of the fraction, the numerator. So it really becomes a 2 because 6 divided by 3 is 2, and then on the bottom, Mason, the z is to the 4th. So the root is really dividing because it's the denominator of your fraction, so you're dividing that out. Questions? All right, so looking down at number 9. Number 9 says take f of x times g of x. But in the problem, f of x has 3 separate terms, g of x has 3 separate terms. So we're multiplying 2x squared, 3x to the 1/2 minus 5. And then we're also multiplying x minus 4x to the 1/2 plus 1. All of that gets multiplied together. So when you're taking 3 terms and multiplying them by a different set of 3 terms, what are you actually doing to get that multiplication? Sam?
You're foiling.
So in this case, it's not foiling because foiling is with 2 terms times 2 terms. Yes, it's the same process. But what are you doing to...
You're multiplying them together.
Yeah, but what are you multiplying?
Factoring? I don't know. About this.
Virginia? So in the first one, it's almost like distributing. So like you have a 2x squared, you're going to distribute that to the back. So you're taking the first term, you're distributing it to the 3 parts in the back. Then you're going to do the middle term and distribute it through, and then the last term and distribute it through. However, you got to be careful because these exponents are fractions. And you have to remember the properties of exponents when you're working with fractions. So the first set here, we have 2x squared times x. So that makes 2x to the 3rd. Because you're adding the exponents, there's a 1 and 2, so that gives us x cubed. The next set is the one that's a little trickier. So we have a 2x squared. We're multiplying that by negative 4x to the 1/2. So you have to multiply the whole numbers. 2 times negative 4 makes negative 8. And then you're adding the exponents. So we're adding 2 and 1/2 together. So multiplying the big whole numbers, adding the powers. Bless you. So that would be 5 over 2. Because 2 is really 4 over 2. So 4 over 2 plus 1/2 makes 5 halves. So this will be 8x and then to the 5 halves. So 2 plus a half is 2.5, but that's really 5 halves. And then the last term, that one's easy here, 2x squared times 1 is just 2x squared. So that's distributing the first term through the back parentheses. And then you need to repeat that process for the middle term. So looking at the 3x to the 1/2 times x to the 1st. So again, you're taking 1/2 and you're adding 1 to it. What is 1/2 plus 1? Virginia? 3 halves. I'm just going to write it underneath to save space here. So we would have 2x to the 3 halves. How about, no, not 2. 3x to the 3 halves. So my 3 and the x. So now taking this to the middle term, so multiplying the numbers, 3 times negative 4 is negative 12. Adding the exponents, what's a half plus a half? A whole. So that just stays as negative 12x, because when you add 1 half plus 1 half, you get the value of 1, the whole value of 1. And then my last term here with the 3x times 1. So that gives us 3x to the 1 half. So one final term that we have to multiply, and that's the negative 5. So the negative 5 is just a number. You don't have to worry about exponents because there aren't any x's to add with it. So we have negative 5x. Negative 5 and negative 4 make a positive 20x to the 1 half. And then negative 5 plus 1 makes minus 5. So I chose to stack them. You didn't have to. You could have written it like as a large problem. But then you're kind of seeing each piece as it's being multiplied together. So is there anything else that you have to do with the problem? H?
You have to combine all the terms.
Yeah, any like terms that you have to be combined. And there are a couple up here. So just starting at the beginning, your powers should descend in order. So it should start with the largest power and they should go down to the smallest power. So the first one is 2x cubed. There aren't any other x cubes. So remember, like terms now, those are the ones that get combined together. We have an x to the 5 halves. So looking, there are no other x to the 5 halves. So that doesn't get combined with anything. X squared, no other x squareds. X to the 3 halves, so that stays the same. And now we have an x, and there is another x because we have a negative 12x and a negative 5x. So now we have a pair of like terms that we can combine together. So that's negative 17x. So they're the same power, the same variable, you add the numbers in front. Looking at the next set here, we have a 3x to the 1 half and a 20x to the 1 half. Again, those are like terms. You've got the same variable and power. So adding those, you get 23x to the 1 half. And then the last little number there is a 5, and there's no other value that's by itself, no constant term to add it with. So you multiply, you end up getting 9 terms, and then there are really only 2 pairs that can be added together with the like terms. Questions?
So why can't you because something raised to the 1 half is just the square root. Why couldn't you rewrite that as
You could
3 square root?
Yeah, you could rewrite it if you wanted to. The 3 would stay outside,
Yeah.
and then you just write the square root around the edge. Sure. Sam.
Can I ask another?
Yeah. Are there questions on this one? Okay, Sam, question.
Okay, so right for number 11, I forget how to find the domain. The domain.
So the only one you'd find the domain for would be number 13.
Well, yeah, but I mean, like, see how it's like. Remember how like we're supposed to find the domain like before?
Yes.
So,
So,
I forget how
like-
to find it.
Okay, so if you look at f of x,
Yeah.
what's the power? Is it even or odd?
1.
It's a 1. So it is an odd function. What's the domain of every odd function?
Just like the negative infinity to positive.
Yep, negative infinity to positive infinity. So then looking at the next one, g of x is a fraction, but is there an x in the denominator? No. So if there's not an x in the denominator, the power of this is still 1. It would still be negative infinity to positive infinity. It's only when there's an x in the denominator that you need to worry, because if there's an x in the denominator, it cannot be 0. If there's a square root, it has to be greater than or equal to 0. So those are the 2 things that you need to think about. Is there a square root in the problem? Is there an x in the denominator?
Alright. So I still forget how to do it if there isn't x in the denominator.
If there what?
I forget how to do it if there isn't x in the denominator.
Well, whatever is, like, so say this is flipped, that can't be 0. So if you solve the little equation, what would x not be equal to? So what plus 5 makes 0?
6. I don't think 6. Negative.
If you add the 5 to the other side, Sam, and
Yeah.
solve for x,
Oh.
what do you get?
Negative 5.
Negative 5. So x cannot be negative 5. So Sam, that means your domain is everything but the number -5. So negative infinity to -5, -5 to infinity.
What about when the power of x is like 1/2 or 1/3?
So rewrite it as a square root.
Oh, okay.
So if it's an odd root, then it's negative infinity to positive infinity. When it's the even root, then it has to be greater than or equal to 0.
Okay.
So cube root, like a cube root is okay, because you can take the cube root of -8, you can take the cube root of +8. But it's when it's an even root. So it's only even, like the even roots, so the square root, the 4th root, the 6th root, and fractions with an x in the denominator. Those are the only 2 times that your domain is something else than negative infinity to positive infinity. So number 11 says f of g of 1. So if you look in the middle, starting on the inside of the parentheses and working your way out, g of 1, what does that mean you're supposed to do for g of 1? David? Plug a 1 in for x. So up here it says x plus 5, so that's 1 plus 5, divided by 2. So David, g of 1 is 3, yeah, because you've got 6 divided by 2, so you get 3. What do you do with that then? So you've done the g of 1, you've got the inside part. Now what do you do? Right? You were raising your hand, sorry.
But you then plug in a 3 for the x and f.
Yeah, so we're going to replace g of 1 with the number 3. You plug that in for the x, so 2 times 3 plus 3 makes 9. So f of g of 1 is equal to 9. So start on the inside, get that answer, and then plug it into the outside equation. So you're using substitution with both variables, substituting it into one function, taking that answer, substituting it into the other function. Sam?
We do number 19.
Yeah, that's what I was going to get to, yes. Okay, so if you look at number 19, number 19 says to find the inverse of the function. So remember inverses. The first thing to do is to take the f of x and make it y. Well, that's pretty easy here. And then what are you supposed to do to find an inverse? Like what's the process, the steps? Caitlin?
Replace y for x.
So replace y for x and x for y. So now it's x equals, and on the other side, 4 minus x is now 4 minus y, because she said replace x for y and y for x. And on the bottom, there's another x, so that also has to change to y. So if there are 2 x's, both of those x's has to be replaced with the y variable. If there were 5 of them, they would all have to be replaced with the y variable. And then, Caitlin, what are you supposed to do after you switch them? What's the last step? Solve for y. Well, I guess it's technically the third step, but then you're supposed to solve for y. So we have to figure out how to solve for y. What do you think, Kate? Like a first step here. Yeah, if there's a y in the denominator, or anything in the denominator, generally we want to get rid of the fraction. So if you want to get rid of something, if you're currently dividing, the opposite of dividing is to multiply. So let's multiply by 3y on both sides, which due to one side you have to do to the other. So 3y divided by 3y, that cancels. We just have 4 minus y. So by multiplying the 3y, it's gone from the right side. It's now on the left side. There's a 3, an x, and a y. You are multiplying it to the top, but it because it's in the bottom, it cancels out. So you're not really distributing it through because it's canceling with that denominator. Okay, so Kate said that we had to solve for y. How many y's are in the problem? 2. And if you're asked to solve for y to get y by itself, you probably want those 2 y's on the same side of the equation so that they're together. So if there's a minus y on the right side, since it's negative, probably makes sense to just add it to the left side so that the y's can be on the same side of the equation. Because our goal is to get y by itself, and if they're on opposite sides, you can't really get two y's to be by themselves or separate. So take them to the same side. So when you're adding that, they're not like terms. Like it doesn't make 4xy, it just makes 3xy plus y. And if you want to put a 1 in front of there to make it have a variable, or a coefficient in front, then you can do that. So add it to the other side so that the y's are on the same side of the equation, that they're grouped together. So this is the tricky part. Our goal is to get y by itself, and it doesn't involve dividing. So you're not going to divide by 3x to take it to the other side. Because if you divide by 3x, you have to divide everything by 3x. So if I divide this by 3x, then that y gets divided by 3x, and the 4 gets divided by 3x. With an equation, what you do to one thing, you have to do to all. So we can't divide by 3x. Paige?
Can you multiply by 1 over 3x?
So if we multiply by 1 over 3x, again, like this still gets multiplied by 1 over 3x. Mir? So Mir said you could pull a y out of the equation. Why would you want to do that, Mir? So if you notice up here, and this is similar to that one problem we did yesterday, factoring is a way to get a variable by itself. And if they both have the same variable, that's called the greatest common factor. That's the first type of factoring you learned way back in like 6th or 7th grade, when you were just kind of starting to pull things out and looking at things in factored form. So both of these have a y in common. That's the variable we want to solve for. If they both have something in common, you can factor it out. It's still in the problem, and now it's separate, and she said you would have 3x plus 1 inside, because when you're pulling it out, you're taking it away from what you currently have. So instead of like dividing the 3x out, if we try and pull the y out, now we have 3x because you took out the y, and it's just a plus 1 because again, there really is a 1 here. You're taking the y and you're setting it outside the parentheses, and that's equal to 4. That's the greatest common factor. If I distribute y back through, I would get 3xy plus 1y. So pulling that out of the problem. And then Mira, what did you say after that to get y by itself? Yeah, so here's y. It's almost by itself. We are going to divide, but we're dividing by the 3x plus the 1. So eventually we're dividing. We just have to do a step first in order to get to that division step, and that step would be to separate the y.
How do you know which problems you're supposed to factor out and which problems you're supposed to divide?
The only time you would do that is if there are two x's in the problem.
Okay.
Don't forget to write it in your inverse notation. Yes, I will take off if you don't have that inverse notation. On every homework problem that I've looked at, I've tried to circle it, remind you to write the inverse notation. So your answer would be the inverse of f. Pretty sure this was the other. Yeah, this is f. And then you have 4 divided by 3x plus 1. Questions? Are there other questions that you wanted to go over, Sarah?
29.
Oh yeah, 29. There was a lot of questions about this last period. All right, 29 says 10 minus 3, the cube root of 2x plus 5, plus 2 equals negative 12. On the left side of the equation, which ones are the like terms on the left side? Caitlin?
And then 10 and 2.
The 10 and the 2. So 10 and 2 are both like terms. They're both constants. So if we add them together, that gives us 12. When you're dealing with radicals or exponents, your goal is to get the radical or the exponent by itself. So we now need to try and get that radical, exponent, whatever we're working with here, it's a radical. We need to get that by itself. So what else would you do? We combine those like terms. So what else can we do, Paige? So yeah, let's take that 12 to the other side to combine it. So that gives us negative 24. And then, Paige?
You can divide negative 24 by negative 3.
Great. So So to get the radical by itself, there's still a negative 3 in front of it, so let's divide by that negative 3. So now we have the cube root of 2x plus 5, and that's equal to 8. So how do you solve for a cube root? Is
You
it?
cube both sides.
Yeah, you cube it. So cube both sides. Do you know what 8 cubed is?
No.
No, not off the top of your head. Aaron does.
512.
Oh,
Am I right?
yeah.
Oh. Okay. That was
Sorry, Aaron.
Sorry.
Were you gonna say 512, Aaron?
Yes, I
Yes.
heard you say it.
Is I hear him say it too? Is that what it was?
Probably.
Probably.
I sucked Aaron's brain.
You sucked it out of his brain. So your cube root and your cube cancel. That just leaves us with 2x plus 5, and now we just have to solve for x. So if you subtract 5, you get 507, and I know this is an ugly answer. 507 over 2. Not a typical fraction you're going to see a lot of, but it's 507 over 2. Sam.
Okay, so you're over 13.
If we wrote that as a decimal, would you take off?
No, but like why? Like that
It's an ugly fraction.
Yeah, but like
Even uglier decimal.
5 versus an ugly fraction.
yeah, but it's still 1/2. I mean, like that's some extra stuff if you're relying on that calculator to put it in and write it as a decimal. Like why?
253.
Yeah. Sam, you said 13? No, I just wrote in the space of 13. We did 11. All right, Sam, what's what's g of x?
What's g of x?
Yep.
X plus 5 over 2.
All right, so we're going to take out the g of x part in the little problem. So we're taking it out. We're going to replace it with whatever its equation is, and its equation is x plus 5 over 2. Sam, do you remember what you're supposed to do with that equation then?
Yeah, you would say f of g of x equals 2, and then x plus 5 over 2 plus 5.
How about plus 3?
Oh, yeah, sorry.
Okay, so if I take this 2 in front and make it 2 over 1, what's the little trick that we can do with the 2's? Virginia? We can cancel them, because if I'm multiplying by 2 and dividing by 2, they can cancel out.
Oh,
So the 2's can cancel, leaving us with x plus 5 plus 3, which is just x plus c. You could also distribute and then divide both. It's going to work the same way. So I would have 2x plus 10 divided by 2, and then I would have to divide both of them. But they can cancel if you're multiplying and dividing.
so the domain range would be negative infinity.
Exactly, the domain and range will be negative infinity to positive infinity. So there isn't a fraction in my problem, there's not a value underneath the denominator. So negative infinity to positive infinity. All right, so I want to give you about 15 minutes to work. I will walk around and answer questions that you have. So I'll be sure to come around and try and get all of your questions answered. When you come in tomorrow, please have your review worksheet out. Try and remember your previous class that you want to take it out. It's going to save you time. You can just give it to me, and I can give you the test so that you can start it immediately. It is only 3 pages, so it's front, back, front. It's 60 points. So the problems, like most of the problems, are worth 3 or 4 points because of the multiple steps that are involved in the problems. Truth. Yeah, I'll come back. So review worksheet due tomorrow, test 60 points tomorrow, chapter 6. Grab a partner, get to work. I'll be around to answer questions.